Welcome to statics. This problem concerns a shaft that goes through A, B, and extends to E. And our job is to find the force and the reactions at A and B. We notice that the connection at A is called a thrust bearing. And what this means is that on our free body diagram of our system, given by X, Y, and Z, already indicated by the problem statement, that over here at point A, we have a force in the y direction, a reactive force in the y direction. We have a reaction in the x direction that I will call AX, and that because it's a thrust bearing, we also have a reaction force in the z direction. So we have an AX, we have an AY, and we have an AZ. So that's what's going on at A. The connection at B is a journal bearing, and that means that support is possible. Sorry, I put that in the wrong spot. That means that support is possible, and I'm talking about the position here at B. So we have a BY and we have a BX. Now, normally, a journal bearing also could have reaction moments. However, we're told that these bearings are properly aligned. Properly aligned translates to being no moments. All right, so that's what you get out of the words properly aligned. So we also read that we have a 500 Newton weight wrapped around a 12 centimeter diameter. Well, that's 0.12 meters, and the radius of that would be 0.06 meters. And so right here we have a 500 Newton force pulling down, and its distance away from the shaft is 0.06 meters. And then we have a force pushing down F over here, which we are trying to find. All right, so we have AX, AY, AZ, BX, BY. That's 5 unknowns from the reactions, and we also have the 6th unknown of the force. So we have 6 unknowns. We're going to probably need to use all of our equations of equilibrium in 3 dimensions. Okay. So to get started, I mentally have already noticed that there's only one force in the z direction. So if I add up the forces in the z direction that equal to 0, I'm going to immediately see that AZ is 0. So I'm going to write that down and hang on to that one. Second, I noticed that there are 3 forces in the y direction. So not going to get too far with that. We have 2 unknowns in the, previously 3 unknowns in the y direction. We have 2 unknowns in the x direction. So I'm going to start with doing a moment, and I'm going to think pretty strategically about which moment, what kind of moment to do. And what comes to my mind is thinking about doing summing the moments along an axis, and specifically the z-axis, and setting them equal to 0. So I'm thinking about rotation, right? I'm thinking about the potential for rotation along the z-axis. And so this 500 Newton force would cause it to rotate in the positive z direction. So let's start noting that down. We would have 500 newtons, and we would have the distance of 0.06 that we already described. The second thing that we would have would be that we have this force over here on the side pushing down, and that's going to cause rotation in the opposite direction, so that will be minus this unknown F, and the distance involved here is 0.25. That's distance from the axis. And so what else? Well, BX and BY are going through the axis, and so are AX, AY, and AZ. So we actually only have one unknown, and that was a great selection of starting point. And so therefore, F equals 120 newtons. And we have 2 of our objectives satisfied so far. So F up here is 120. And AZ is 0. So all of a sudden it's getting a lot more doable. So continuing along this notion of thinking about moments along axes, I'm kind of inclined to set an axis up, and I'm going to change colors so you can see what I'm doing. Let's choose green. I'm inclined to set an axis up at B and to think about this sort of, I'm going to call it an x prime axis, to think about taking the moments along the x-axis at B. So let's go ahead and write that down. Moment x-axis at B. And setting that equal to 0. So Bx and By are going through it, no big deal. F does have the potential to cause rotation. That will be, if you think about it, that would cause a positive moment. So we would have a positive F. The distance involved there is equal to 0.3 plus 0.4, which is 0.7. These are meters. Then we have the 500 Newton force could cause a moment about the x-axis, and that would be a negative rotation. So we'd have 500, and then we'd have a 0.8 distance away. That's given to us nicely. And then we also have to think about the rotation caused by AY. We do not have to think about the rotation of AX because that's aligned with the x-axis, so it will not contribute. And we do not have to think about AZ because it is 0, and it goes through this. It goes through the axis as well. So relative to AY, we would have a positive AY, and the distance there is 1.4 meters. So we've got, since we know F is 120, right? We only have one unknown, and this yields that AY is equal to 225.7 newtons. Now we can sum the forces in the y direction, set them equal to 0, and so that we will get that 225.7 plus By minus 500 minus 1200 equals 0, and therefore By equals 1474 newtons. And we can round that off to be 1470 newtons. Last, we need to figure out what Bx and Ax were. And so if we look back at our diagram, if we now set up, if we now consider, and let's just change color again so you can follow. Let's change to purple. All right, let's now consider an axis going on here, and let's sum the moment about the y-axis at B and set that equal to 0. And so if we glance back to our problem statement, so the 500 Newton is going along the axis, so it will not create a moment. This will not create a moment. Bx and By also won't create a moment because they're going through it. AY will not create a moment. AZ is 0, so the only thing available to create a moment is AX. All right, well, since we're in equilibrium and there's only one thing contributing, we can conclude that AX is equal to 0. And if I can just kind of articulate that, what I'm saying is that AX, if it had a value, right, times 1.4 is equal to 0. Therefore, AX is equal to 0, and also Bx is equal to 0 because when we sum the forces in the x direction, we would conclude that Bx is equal to 0. So in summary, in looking back, when you see problems where there's rotation of an object around a shaft and there's a force and a load, I would suggest you begin by summing the moments about that axis, because that is a quick way to kind of get to that first unknown, which sort of unlocks the rest of the problem. All right, that's it.